so now I have another example of the same process going from the y versus x graph of a wave to the y versus t, but now I have a slightly different wave. Same scenario though, I like to use the same scenario where I'm thinking that I'm relaxing in the sea. It doesn't happen very often these days. So I am here, and again, I'm gonna do the y versus t graph for my location, for my specific x. And now I have this kind of wave. Now you can see that the wave has two different parts, so this is a little bit more complicated. Let's say I'm gonna use the same numbers. The distance between me and the first part of the wave continues to be 10 meters, and the wave is traveling at 1 meter per second. So I know that from now until the moment the wave hits me, I'm gonna be relaxing in the sea at y equals 0. So for 10 seconds, this is gonna be 10 seconds. Now, okay, I need to think. So the wave has arrived and it is here. Now I want you to see something. As the wave keeps moving to the right, you can see. So at this point, I'm at y equals 0. At this moment in time, I'm a little bit higher than that. And then I'm a little bit higher than that. And then I'm a little bit higher than that until I reach the maximum y. So, because my y increases gradually, I'm gonna reflect that on my y versus t graph, right? This shows that I'm relaxing in the sea until 10 seconds, and then this is the first moment the wave hits me. And because it is this part 1 of the wave, that hits me first, I am going up. My y value increases in the same way that part 1 of the wave shows here. So this is my increase in my y, in my height, because of the first part of the wave. Now here I have reached the maximum height. Okay, this is the highest point of the wave. And now as the wave continues to move to the right, my y value, my height, keeps getting smaller and smaller. But you can see though, the shape of the wave here is not the same as the shape of the wave there. It takes much more time. It will take me much more time to go down to y equals 0, because this part of the wave is much longer. So the way that I'm gonna reflect that here is by doing something like this. I am going down to 0, but it just takes me more time, and that is because this part of the wave is longer. So this is, and then after the wave leaves, of course, I will continue to relax at y equals 0. Now, this is what the y versus time graph of this wave looks like, and I want you to compare. This is the snapshot. This is the y versus x. This is what it looks like. And this is what the y versus t looks like. It may give you the impression that it is a mirror image, and yes, it is. Now, I do want you to understand that there is no rule that says the y versus t graph will always be the mirror image of what you have as y versus x. It so happened to be like this in this case. What is important to understand is the process. Okay, the process that I'm using to go from the y versus x graph is the one you need to use to determine the y versus t. Now I'm using a transparency and I'm using a specific example, but this is, in my mind, this is how I think about this. I'm thinking about the wave, the y versus x graph, arriving at me, hitting me, and then I move according to what the wave looks like, and then in my mind I'm translating it to the y versus t graph. Okay, always follow this process, because this process will never get you to the wrong result. Sometimes it may happen to be a mirror image, sometimes it will not. There is no rule. I do strongly recommend understand this process, follow it every time you need to, and you will not be getting wrong results.